Guess what I almost forgot to do is respond to myself in a video. Okay, let me set this up. Okay, this is my notebook, and this is an empty page. Thank God. I have workmates in here. Imagine if I flipped something bad. Anyways, mind you, I also have video game related notes from videos. Anyways, what did I want to do? Oh yeah, Pokemon. How, let's title this video, how RNG, oh jeez, let me look at the paper instead of my phone. How RNG might also work in Pokemon. This is an accent aigu, for those of you who don't know. Pokémon Stadium 2. So, I wasn't even filming. Wow, okay. So how Pokemon Random might work. This is the video. So, in the video, I talked about a couple of things. I did talk about a couple of things, but basically what I said is that all of the calculations are done before, and they're stored in some sort of array. So basically what I said is, you start a match of Pokemon, and you have some sort of array, or back then I'd probably assume it's some sort of very basic, very primitive stack, and you store all of your random numbers. You have A, B, C, D, E, da, 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 da. Okay, so these are your random numbers. Each one of these is a random number, and then you've got your dude over here with the ears, and you've got your other dude over here with the boxing gloves, right? And when this guy wants to do an attack, he's like, let me use my Thunderbolt, right? And then Thunderbolt grabs a random number from this. It pops A off of the stack. Bop. A is now here. It's gone from here. It takes A, uses A to make some calculations and some magical, random number logic maker, whatever, and then based on that, it determines whether or not Thunder will miss, whether or not Thunder will hit, or whether or not Thunder will critical freaking hit wreck this boy, right? Okay, so that's what I said, and I said this because I was able to reset my save state basically from the beginning. So I could basically pop off A, this guy pops off B, C, D, E, F, G, whatever, I know all of the outcomes, what's going to happen, whether it's going to be a critical hit, whether it's going to inflict a poison, all this stuff, right? And then I could do this, I could get to a failure state, right? And then I say, well, nah. So then I reset, A, B, C, D, E, F, G, and here's the magic. It's the same A, the same B, the same C, the same D. So basically you can reset to the beginning of the game, and you can now, knowing exactly what's going to happen on every turn, take advantage of that to be the enemy's perfect opponent, is what I concluded before Kendrick Lamar popped in and told us about what he thinks about Photoshop. So, here's the thing. I said at the beginning, because there is another possibility of how this would work, and I didn't think it would matter that much, but I feel like I'm lying if I don't do a follow-up like this, because there's another way that actually makes more sense given the context. It's just the research I did didn't necessarily support it. So that's number one. Number two, if it is done the other way that I'm going to explain now, there actually is a security flaw, and we're going to talk about that. And that's why I didn't want to bring that up, because that would have been a whole different thing, and that would have been a much more interesting topic. And I had tried to see if that was it. There was a way I could have tested it, and I tried. I probably didn't do as good of a job as I could have, but I did try for a while, and I wasn't able to basically do the one thing that I thought would happen. But anyways, and the other thing is, what is the other thing? So in the beginning of the video I said, I'm not saying that this is exactly how it is, but I'm saying that the description I'm giving is behaviorally identical to however it's implemented. Basically, it doesn't really matter how it's done. This basically matches it, so any conclusions I make based off this are the same. Basically, what I'm saying here is that the way it might also be done is behaviorally equivalent to this, although there's one thing I could add, one additional consequence, which we're going to talk about now. So, let's talk about pseudo random number generation. So in the video I touched on this a little bit. Generating a real random number is a little bit tough. What do? We use a seed. What is a seed? It's randomness that we pull in from the universe. So, for example, if your computer has a freaking thermometer, this doesn't look like a thermometer, but if it did, you could take the temperature, although that's not very random. You could, if you have an antenna somehow, you have a router that you connected to, and there's, static interference from the Big Bang, not the TV show. Though that'd be pretty funny if you made a random number generator based off whatever episode of the Big Bang is airing. That'd be pretty funny. But I'm saying the real Big Bang, which, when you turn on your TV, that's the static you see. Anyways, whatever. You don't care. So there's a lot of different sources of randomness you can get. In the computer, for example, you may have something called a count register, which is basically this thing that does a bunch of stuff. So it basically, okay, all you really need to know about this is that at any point in time, the count register can hold a different number, okay? And it depends on the activities of the console, but the activities, basically what the console is doing differs from console to console, from startup to startup. If, somebody's been playing for half an hour and then they started a new match versus somebody who played, one game and then switched games and then played another game, you're going to have different numbers in your count register. Basically, the idea is that though it is not random, from the game's perspective, which is not in control of the count register. I'm sorry, by the way, for the focus. Something's wrong with my phone. But what is happening? Whatever. So basically, the idea is that from the game's perspective, this is the game. It's not a tombstone, but whatever. From the game's perspective, the count register is outside of its control. So whatever is in the count register is unpredictable to the game. Which is actually not true. But let's just cut it off there because we don't care about this. So that's how I said it worked, was that it uses this count register. But what if, and there's a big if, this is a type of pseudo-random number generation. The number you're getting is pseudo-random. It's based off this seed, which is whatever, and that's the rest of it. And there's another way you could do this. Now, let's say so in Pokemon it was like, RNG is equal to, what was it? It was an addition and a multiplication. So let's say it's like, A times seed plus B, right? Why did I do a capital B? Okay, this is a capital A. Oh. So RNG is equal to A times C plus B. So A is some preset number, B is some preset number, and the seed comes from the count register, and that's how you get your count, right? And the B is probably just there as like the minimum. So if seed is ever 0, B will be the basic random number, some basic stuff like this, right? So based on my research, what I found out was that the seed comes from this, and this is the weird stuff. So it basically, the description didn't really make sense, but what I interpreted from it was that the seed comes from the count register, which is pure random, but then based on a number of factors, which include the random number previously generated, so RNG at t minus 1, okay, at time minus 1, this random number, and the count register. Based off these, it would generate a number, let's say an array of random numbers, and then it would take all these random numbers and put them in an XOR, which is called an exclusive OR, because these are in binary, right? So each one of these numbers is actually really just another list of zeros and ones and zeros and ones and whatever, right? So then it took all of these, put them in an XOR, and it outputted the final random number. So actually every random number generated is really like 200 random, like who knows how many they're doing, right? Now, there's another way to do this, which doesn't involve storing them in a list, and you get basically the same behavior as storing them in a list and making it so that it's completely identical, so that if you reset to this point, all of the future ones will be the same. And how do you do that? Well, very easy. RNG is equal to A times RNG at t minus 1 plus B. All right? So what does this mean? And this obviously excludes the base case in which you have no previously RNG, which at that point you would either choose B or you would, for the base case, do something purely with the count. So let's say this is the random number generator, which actually this is how a couple of systems that you can name drop use. For instance, in MySQL, this is what random number generation is. So if you don't pass a seed, it'll use a random seed, which is a little bit hard to explain. But if you choose to, then the random number generated will always be the same. What do I mean? Well, here's the idea. So if on the first turn you generate the random number x, well then the second number will just be a times x plus b, right? And let's call this y, okay? And then the next one will be a times y plus b, which we'll call z, right? So the idea is that whatever the value of z is, depends on the value of y, which depends on the value of x, which means that z technically depends on the value of x, which means that every future random number just depends on that first random number, right? And now the reason I didn't want to say it was this, because I really didn't want to believe it, but it's very possible that it is this, is that means that if you know x, you know everything that's going to happen throughout the rest of the game. It's not even about having to explore all of the future variables, because these ones are not independent from each other. They're all dependent, which is one way to do it, and you get the same exact behavior. So this is the idea. If the game, and this way there's less storage being used, which is why I'm starting to think this is maybe how it works, and I maybe misinterpreted the results I was reading on Bulbapedia. But anyway, so the idea here is that let's say you play a game and you've progressed and you've generated 100 random numbers up to this point, right? If you reset and you go back to this point, right, where x is the only random number, these numbers are all wiped from memory. They've never been generated yet. As far as the game is concerned, these numbers do not exist. They've never affected the game. But this number still exists, right? X, which is the root of our random number equation. It's our first seed. And if x is the only seed in the random number generator equation, which is this, then what will happen is that when it generates y, it'll be the same exact y that was generated the first time. When it generates z, it'll be the same exact z that was generated the first time, and so on and so forth for all of the future letters. Good thing I finished at z, because I would have run out of letters. Anyways, so here you get the same exact behavior. You can reset and explore the rest of it. Now, in this implementation, which is the one I said I believed in, which I'm starting to doubt. Oh my god, the focus is awful. So in this one, there's not really a security flaw other than being able to reset your memory. So in a normal playthrough of the game, you can't learn so much about the system that you can predict the outcome of the next match. No matter what match you're in, you still have to play through the entire match to understand what's going to happen and then reset, right? You can't start from this point fresh for the first time and know exactly what's going to happen. Whereas in this implementation, if you know X, you know what's going to happen next. You can plot it out. You can just do the math, right? Which is what I was saying about with testing this. So basically the idea is, and it's hard to test it exactly, but let's move on to this page. So we were talking originally about numbers between 1 and 100, random numbers, and this represents the accuracy of an attack, right? So 0% to 100%, and I put the percents on the wrong things. But so here's the idea. Based off this equation, which is just a multiplication and an addition, odds are, let's say your first random number, let's say random number at time t was equal to any range between 0 to 10%, right? So let's say the RNG was this, the first one. Odds are the result of this, of any number between 0 and 10, is going to be the same, because attacks either miss, they hit, or they critical hit. There's not much. So odds are this is going to be the same, which means that when you use this value to get the RNG at time t plus 1, odds are, it doesn't even matter what the range is. You don't need to know exactly what it is, but odds are the outcome of this equation, the next random number generator, will have the same outcome as any number between 0 and 10. So, assuming that there's no really complex logic. But basically what I'm saying here is that there is a security flaw. So if you can predict the first number, let's say the first attack in a round is a critical hit, and you know, guaranteed, that a critical hit is between a 90 and a 100. Well, if you know this, then you can get a pretty good idea just by tracing the outcome of events, after this. You can get a pretty good idea of what number you're at based on the starting point. So if you know that you're between a 90 and 100, you could even just do 10, versions of it. Eventually you get kind of crazy, but you could basically start building a pattern. So basically the idea is if these numbers will always come out to the next random number, RNG at t plus 1. If this number, based off of this range, will always have the same outcome, then the next time you have a critical hit, so let's say you had a critical hit and the next outcome was a move that missed, let's say, So let's say anything between this and this, the next move will miss. Well, then you know that the next time you hit a critical hit, you know that the next random number will result in a missed attack. So instead of even bothering attacking, you might want to do something like switch Pokemon, do something that's, well worth your time because guaranteed that it's going to miss. So that's what I'm saying. And then after a miss, you identify that the next outcome will be something with a status effect, right? And then you're like, oh, okay, so now I know how to change. So now I know that a critical hit always results in a miss, which always results in a status effect. And then at that point, once you've mapped it out once, you get a pretty good idea. I mean, even if in ranges like this, you have a 10% chance of being correct, right? In the worst case, I guess, right? So that's a problem. Now, again, virtually equivalent to this, with the exception of, first of all, it saves more space on the N64, which is probably a priority back then. But second of all, it can be exploited to destroy the entire game. But this is very possibly how you do this. And there are reasons. Now, you might probably, let me just finish with this. You might be asking, excuse me, why I'm such an idiot. Well, that's because I haven't been in school for a while. But it's okay, because I'm working. And this knowledge comes from work. So one of the problems we had to tackle, I don't know if I'm allowed to talk about this, but who cares? One of the problems we had to tackle was we have a page where user data is displayed on the page, and it's without going into too much detail, it's something where you don't want users to be able to exploit the system. So the idea is that you have kind of a landing page where you see detail tiles for 3 users. You see their little pictures with their faces, let's say it's like Facebook or something. Yeah, let's say I work at Facebook, that'd be funny. So you got 3 little details, right? And then there's a button that says View All. And when you click on this button, you actually view all of them. Now, this result, just to be fair, because there are actually, let's say hundreds of results, maybe more, who knows? We'll see what happens. Let's say there are 100 results, and you're only showing 3 here. So what we do here is we just made it pure random, because you just want to do it that way, right? But once you hit the view all, you don't want it to be purely random, because eventually you get to a page where, now instead of 3, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And then you have at the bottom pages with arrows, and you can select, left, right, or you can choose a page number, 1, 2, 3, 1, 2, 3, drink, 1, 2, 3, 5, 6, 7, 8. So you do this, right? And you got all your little, why am I bothering to draw these dudes? Who cares? So you have these, right? Now, you don't want it to be completely random every time, because when you click on this page, on page 1, you'll get a result, and if you click on page 1 again, well, you'll get a different result if it's purely random, right? Which is stupid. So we had to come up with a better solution. So what we did, because MySQL handles this the exact same way, it actually just takes the last random number generated and plugs it in. If you set a seed, you can have the same result appear. So what we did basically is instead of this being random every single time, the random number generator, let's say it's a function, we passed it the date number. I don't know what the date, anyways. So the date number is like the number in the date, in a date time. So we just get the current date of the server and we're like, hey, it's the 5th today. And then it's like, okay, so it uses the 5th to generate a random number x. It uses the number 5 to generate x. And then it uses x to generate y. And then it uses y to generate z. And then it goes on and so forth. So basically on the first, on here, it'll use this random number, then it'll use this, then it'll use this, and then basically, so you seed it like this, and it's beautiful, and you'll get the same result every single time. What am I even talking about? No, wait, we didn't generate random. No, that wasn't the point. What am I talking about? Sorry, this has nothing to do with what I was talking about. This is completely false. The idea was that in actually, no, that was correct, but for the wrong reason. So in normal MySQL random number generator, basically every time you generate a random number, it generates the random number x, and then the next time you ask for a random number, it uses x to make y, and then it uses y to make z, and blah, 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 blah. And the problem with this was that every time you click page 1, it uses x, then it uses y, then it uses z, and that's a mistake. So, blah, 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 blah. Instead, we pass it the date number, so every time on the 5th of September that you visit the page, it'll always output the same result. And you can go to page 2, 3, 4, 5, every single one, they'll be the same. Whereas, if it's now the 6th of September, so it was the 5th before, now it's the 6th, well, this result, page 1, will be different, but it'll be same throughout the entire day. So that's a good use of pseudo-random number generation. You can, if you need the same result, the same random result, you can use something like this to do that. So that's why these sorts of things do exist, because obviously I feel like when I explain this, it might feel like there's no reason to ever do it like this, but this is one of the reasons. You can imagine that this is very useful to do stuff like this. In a game like Pokemon, not really, but again, at the same time, well, no, not even actually, because in this implementation where they're all random, completely independent from each other, you can't really know what's going on. Whereas here, well, as long as you know X, you can predict the rest of it. And that's how random number generation might work in Pokémon Stadium 2!